Hi guys, welcome back to the continuation of exothermic and endothermic chemical reactions examples. We have started the chapter of energetics of a reaction. We just have discussed in the previous lecture what are endothermic reactions and what are exothermic chemical reactions. We have started the examples of endothermic reactions. So we can say this thing that bond breaking is endothermic. We were considering a pencil. I am going to consider that thing again. Right now, I am on a new page. I can tell it to you. For example, if you have this glass rod, or if you have a rod of, like, for example, this is a rod which is a wooden rod. You may say, okay, a wooden rod. Okay, so if you have to break it into two parts, you have to give in the force. You have to give in the energy here. Okay, so that's why we can say this thing that bond breaking is endothermic process. Okay. If bond breaking is endothermic, so definitely bond making is opposite and bond making will become exothermic. So I am writing here bond making is exothermic, which is opposite to that of endothermic reactions. Okay, I am just changing the page and we have just started the examples. Here I'm telling you that from solid to liquid and from liquid to gas or from solid to gas directly, all of these processes are absorbing heat energy. As a result, we can say this thing that heat energy is gained. So these processes are endothermic processes, whereas opposite processes, that is a gas is turning into liquid, whereas a liquid is turning into a solid back. So those processes are losing heat energy. So that is called as exothermic chemical reactions or exothermic processes. Okay. We cannot consider them as chemical reaction, as no chemical reaction is happening in this, as no chemical change is occurring in this. These are all the physical changes. We are just providing the heat energy. For example, a solid can be liquid and we are losing the heat energy. A liquid can become solid back. So these are considered as physical changes, physical processes. Okay, now I'm giving you a few more examples regarding endothermic reactions. Okay. After endothermic, number one was melting. And number two is, you may say, boiling. We may consider these physical changes as like one, but for your convenience, I'm just writing that as these are the processes which are happening by absorbing heat energy, so you may consider them separately. So this is sublimation as well. And here I am giving you the fourth example, which is photosynthesis. You know this already. Photosynthesis is a topic which students are studying right from the beginning of their science studies. So we know this thing that it is a process which is happening in plants and that is related to their food preparation. We can say this thing that in this process, actually, sunlight is absorbed by the green color pigment of the plants, and that green color pigment of the plants is called as chlorophyll. Chlorophyll is existing actually in the specific parts of the plant, specific parts of their leaves, actually, which are called as chloroplast. Sometimes the green color pigment is not green colored. Might be you have seen some of the plants have the leaves of red color or pink color, etc. So that is the different colors of that pigment, but that remains a chlorophyll. So we are not concerned with the locality of the chlorophyll. We are just telling you, by the way, that chlorophyll is existing in chloroplast. Okay, so I am just telling you here, it is actually 6CO2 plus 6H2O, and this is chlorophyll. And these are the conditions for the reaction which we are writing above and below the arrow, and that is the sunlight which is needed for this process. And after this whole thing, it is converting itself into C6H12O6. What is C6H12O6? That is called as glucose. Here I am writing, this is the formula for glucose along with 6O2 as well. So we can consider this thing that as this heat energy is absorbed in this process, so photosynthesis is considered as an endothermic chemical reaction. Okay. Now number five is on the new page, and that is a very important process. It is called as thermal decomposition. Thermal decomposition reactions are also decomposition reactions are also considered as those reactions in which heat energy is absorbed. So here I'm writing heat energy is Absorbed. Okay, I am just saying you one thing very clearly, that for example, if you have a metal carbonate CaCO3, we are going to provide it heat. As a result, it is going to convert itself into CaO and CO2. So metal carbonates are thermally decomposing to give you CaO and CO2, depending upon that metal carbonate. So for example, if we are considering zinc carbonate, it is another type of thing, and another type of an example. This triangle is, you may say, plus triangle, plus triangle. It is just telling you that heat energy is absorbed in this case. One more thing which students should remember, and that is should consider while considering such type of the reactions, that depending upon the different metals reactivity, their compounds will require different amount of heat energy for their decomposition. So for example, we know this thing that sodium is a very reactive metal, and its carbonate must be a very stabilized type of a compound. So that's why it must be requiring lots of heat energy. It is quite a very stable compound, so it is requiring lots of heat energy for thermal decomposition. So here I am saying you, this is going to take you zinc oxide, and CO2 will be formed in this case. But when we are talking about zinc sodium carbonate, it is going to give you what? Na2O along with CO2. But this reaction is specifically, I am mentioning very clearly, it is advised to the students that instead of giving the examples for such stabilized compounds, it is good to give the examples for those compounds which can thermally decompose easily as compared to very stabilized compounds. There is another example as well you may consider, that is requiring very lesser temperature. Why it is so? Because copper is a very low reactivity metal. As a result, it is requiring a lesser heat energy for thermal decomposition. Okay, I am planning to record the lectures regarding metals and their extraction as well, inshallah. Over there, I will teach you about the reactivity of different metals, how some of the metals are more reactive, how some of the metals are less reactive, on which criteria we are defining the metals reactivity, etc. So here I am just telling you that thermal decomposition is an endothermic process. Examples of metal carbonates converting themselves into carbon dioxide gas, which is a gas which is turning lime water milky, along with the metal oxide are the product. I am giving you another example for thermal decomposition, and that is called as metal nitrates. Okay, metal nitrates are thermally decomposing themselves. For example, there are three different types of the products which can be formed in regarding the category of the metal nitrates. If a metal nitrate is belonging to a very reactive metal, if a metal nitrate is belonging to a mid type of a metal's reactivity, or a very low reactive metal. But right now we are just considering a general metal nitrate decomposition, because right now we are not discussing about the reactivity of the metal. When I will teach you about the metals and their reactivity concept, inshallah, over there I will tell you the different ideas about the metal nitrates thermal decomposition. Here I am just telling you a general type of a thing, like those which are most commonly considered. So for example, it is zinc nitrate, and it is going to give you zinc oxide along with the brown color gas NO2 and oxygen. Okay, so this is the balancing of this equation, that is 2241. That's okay. I am not saying you to keep that thing as a like a rattafayo thing or the memorizing thing. It is good to understand the balancing. So you are going to place a number before the reactants or before the products, so that they may remain in the same formula form, but their number of times the reactants or the products are present, the same element should be there. Like, for example, if two zincs are there in the reactants, two zincs should be there in the product. For example, we may consider this thing that if four nitrogens are in the reactants, four nitrogens should be in the product. We are not allowed to change the formula regarding balancing, but we are supposed to write down those numbers which are just adjusting the whole thing. Okay, so this is a process in which heat energy is absorbed. Remember this thing, that those processes in which NO2 is forming, we are going to perform such type of the reactions in fume coupled. Okay, so fume coupled are those which have a specific type of the exhaust, and they are taking all the fumes out of the lab. Okay, because nitrogen dioxide is a gas which is an acid rain causer. So we are saying this thing that it is an acid rain contributor. Acid rain contributor. That's why we should not it can cause serious type of the problems towards our lungs and eye irritation, skin issues, etc., etc. So if instead of performing this in the lab, what will happen? More concentration will be there, more amount of NO2 will be there in the lab, and it's better to expel it, to exhaust it out of the lab. So that's why this type of the reactions are happening in the fume cupboard. One more example regarding endothermic chemical reactions is cracking. Okay, now what is cracking? I have taught you cracking already in the chapter of organic chemistry. Let me inform you one thing very clearly, that cracking is a process in which long chain hydrocarbons are broken into shorter chain hydrocarbons. Okay, guys, I'm telling you very clearly, you are not allowed to write LCHC or SCHC, etc. type of a thingy in your paper. You are supposed to write the complete word. Okay, so in case of cracking, you have long chain hydrocarbons. So for example, I can tell you this is like a C8H18. So this is an alkane which is called an octane. Okay, why it is so? Because it is having 8 carbon atom, and as it is following the general formula of alkane, which is CnH2n plus 2. So as a result of that, it is going to give you same number of carbon atoms and hydrogen atoms, but shorter chain. So for example, it can give us C4, or you may take C3, for example, or C2H, let's say H6, and C2H4, and C2H4, and C2H4. So you can check this thing that all of them are C2, C2, C2. It means that from the 8 carbon atom chain, a longer carbon atom chain is broken into shorter pieces. So depending upon the demand and depending upon the requirement of examiner, a student is advised to do the cracking products accordingly. But remember this thing, that cracking is a process which is requiring a heat energy. So the temperature for cracking is from 300 degrees Celsius to 600 degrees Celsius, and Al2O3 along with SiO2 is the catalyst of this reaction. So you are supposed to memorize these conditions for cracking. So I'm just telling you that cracking is a process in which a long chain hydrocarbons are broken into shorter chain hydrocarbons. So that's how we can say this thing, that basically cracking is a process in which heat energy is given to a compound, and that compound is broken into its smaller pieces. So here a hydrocarbon is broken into smaller pieces, so that is called as smaller hydrocarbons are formed in that case. Thank you very much, guys. We are going to continue from the examples of exothermic chemical reactions in the next lecture. All the best to all of you. May we all have a good day ahead.